Welcome to this video on fiber optics and use in the lab. First of all, let's take a look at a reel of fiber optic. There are three reels here. We'll look at just one, and these are about 50,000 meters or 31 miles. And the idea of this is to give you some perspective on how thin this fiber optic cable is. If you look at the picture now, you can see the yellow cables which we normally see when we're patching, but if you look very closely, there's like a transparent, very thin cable going into that connector at the top. The fiber optic is contained inside that, and it's actually smaller than the width of a human hair, so it's actually inside there. So we're going to use a microscope to look at the top of our patches. Let's see some patches. Here we are. These are LC connectors, lucent connectors, and they're the most common in our lab. We're going to use a microscope to look at the top of these cables. Obviously, if there's any muck or scratches, it will affect the light going through and result in a link not coming up. So it's always a good idea to clean these before we use them. Little microscope to illustrate what we're doing. Here we are. That's a USB microscope. Now it's plugged into an LC patch cord. Microscope to illustrate what we're trying to do. And this is the USB based microscope. And this is me trying to burn my hand. No, not really. This is showing a light that it uses a blue light there. Into a very old computer, onto a monitor, and we'll see what happens. So let me go and grab a patch cord. And this time I'm not going to clean it. I'm just going to plug it straight into the microscope, and we'll be able to look at the surface of the end of that cap. And there we are. It looks pretty horrible. Just need to focus it a little bit. Obviously the light's going to get really messed up going through there. That's the thumbs down, obviously. So let's clean it. We have a special cleaner in the lab. This is a cassette based cleaner. Every time you press that blue knob down, it advances some clean material in front, and you wipe it in a certain direction, and it should then take off all of the rubbish there that was on there. Now we'll plug it back in and see what happens. It's much better. However, there are still some problems there, as you can see. Just to give a refresher, multi-mode fibre is much larger than single mode fibre. I'll try to do it more or less to scale. The black dot on the left is multi-mode, and the small dot on the right is single mode, and that's called the core. And you can see that the multi-mode is 62.5 micrometers and 9 micrometers for the single mode, so it's much smaller. Cladding is about the same, 125, and then buffer, it's just the outside parts. So the point there is single mode, if there's a little bit of rubbish, it's going to really mess it up. Multi-mode, you might get away with it. This is multi-mode, and all of these images, they're single mode. All of these images are taken from the lab. They're not off the internet. These are taken with the microscope. Yeah, it just shows you a human hair is about 100 micrometers, and that's only 9 for the single mode. This is comparing multi-mode and single mode. Personally, I would highly recommend always cleaning single mode before you ever use it, because of the fact it's so small. Anyway, let's see what's coming up next. Rogues Gallery. Okay, I've put a few crackers here. These are multi-mode before and after. That's before, and that's after. The scratch is still there, notice. And then these are some random examples are just pulled out and put onto the microscope. And that's how it should be. And this is single mode. Again, we'll look at some bad ones. And these are from the lab again. As you can see, they all need a good clean. Well, that's the end of the video. Hope you enjoyed it. Don't forget to give things a wipe before you use them. My name's Peter O'Reilly, and this is the end. Bye bye.